Hey guys, it's Mary and welcome back to Study Journey. Welcome back to the Python series. This is the last episode, or the 8th episode of the Recursion Problem Set series, and we're going to be going over the last part of Caesar cipher, and this is going to be from section C, and this is going to be the second part where we're talking about the encrypted stub message and also testing our code. So without further ado, let's get into the video. Okay, so in the previous episode, we did part 1, and now we're going to be doing part 2, which is encrypted sub-message. So it says to fill in the methods of encrypted sub-message class found in ps4c.py according to the specifications in the doc strings. So looking at the instructions over here, we can see that given an encrypted message, if you know the substitution used, then decoding it is really important. And you can also replace each letter with the correct decoded letter. But the problem is you don't know the substitution. And even if we keep all the consonants the same, there's still a lot of different ways and options for trying different substitutions for the vowels. So with the Caesar cipher, we can use a trick of testing different uppercase and lowercase vowels to see which ones make the most valid English words. So now looking over here at this class, it says to first initialize an encrypted sub-message object, and the text is just the encrypted message text. And they have two attributes. It is the self.message_text and then self.valid_words. So first, we initiate it with self and text. So first we initiate it with text, and then moving on to the decrypted message part, it says this attempts to decrypt the encrypted message, and the idea is to go through each permutation of the vowels and test it on the encrypted message, and for each permutation check how many words in the encrypted message are valid English words, and then return the encrypted message with the most valid English words. And if no good permutations are found, then just return the original string, and if there are multiple permutations with the same number of maximum words, then return any or all of them. And so we should return the best decrypted message. So first, let's set the vowels permutation, and that is just going to be the get permutations, and then from the vowels lowercase. And then let's set the best vowels permutation. Well, we don't know what that is yet, so let's just set it to vowels permutation, let's say the first one, sub 0. And then also we're looking at the maximum valid words, and right now it is going to be 0, and also we don't know what the decrypted message is going to be yet. So the number of permutations is also unknown for now, so we can set it to 0. And now that we have all of this, we can actually start writing our code. So for every vowels permutation in vowels permutation, the number of permutation is going to be the number of permutations plus 1. And then with this, we're going to call the valid words count right here, and we're going to be updating it as we go. So let's let it be 0 first. So let's let the decryption dictionary be self.build transpose dictionary with the vowels permutations. And then from there, we're going to update the decrypted text to be self.apply transpose, and we're going to be doing it with the decrypted dictionary. So now for every word in the decrypted text, we're going to split, so dot split, the word is going to be the word dot translate with the string, and then we're going to make the translation first, 2 blanks, and then the string dot punctuation. And then so here, if the word is in self.valid words, so if it is a valid word, then the valid words count is going to go up by 1. And if not, it won't. And then now, if the valid words count is greater than the maximum valid words, then we're going to update the maximum valid words to be the valid words count. And then so the best vowels permutation is going to be vowels permutation, so vowels permu. And then the decrypted message is going to be the decrypted text. And then finally, in the end, we're going to return all of it. So the best vowels permutation and also the decrypted message. And so now we're going to move on to part 3, which is testing. So it says to write 2 test cases for submessage and 2 test cases for encrypted message in the comments down here. So it already gives us an example text case where the message is hello world, and then here's the permutation. And so the expected encryption should be this, and we're going to try to see if the actual encryption is going to work and the decrypted message also is correct. Instead of writing a test case, let's Command S, save it, and run it to see if this test case works first of all. So if we're going into our Finder, we can see that PS4 is in CS Practice. So I'm going to open the CS Practice first, and then PS4, and then this is a Python 3 file called ps4c.py, and let's see if it works. So as we can see, there is a syntax error in line 117. So let's go over to 117, and we can see that there is in twice. So I'm going to delete that, Command S, and then do it again. And it says that there is an invalid syntax. Well, that is because we need for I in range 21. So I'm going to save that again. And then, as we can see, here is the original text, and then the permutation. And then, so this is the expected encryption, and then there was some mistake right here again. So that was in line 199 and also in line 135. So let's first look at line 135 right here. And as we can see, there is a spelling error. It's usually the spelling errors that get it, because that is what messes people up. And then so in this line, best values permutation, we can see this is going to be a list, so it is in these brackets. And then 181, it is supposed to be translate. And as we can see, looking at the results, the original message is hello world and the permutation is EAIUO. The expected encryption is this, and then we can see that the actual encryption does match the expected encryption, and then also the decrypted message also matches. So now we have just finished this whole problem set 4, and we first looked at recursion, and then now we're mostly learned about classes and everything else.